So let me give you guys another example. So in this video, we're going to try and understand these parametric equations from negative infinity to positive infinity. So our normal routine would be to create a table. So from this, when time equals zero, x would be 0 squared. So which would be 0. So when time equals 0, y would be 0 plus 1, which is 1. And then when time equals 1, it will then give us this. When time equals 1, y will be this. And when time equals 2, and so on, we would create a table. And then from our table, we can then sketch a graph. Because if you look at the table, hang on, we are trying to understand these two parametric equations. When time equals 0, the initial starting point will be 0, the coordinates will be 0, 1. So you would create your graph. When time is 0, the coordinates will be 0, 1. So it will be 0, 1. So it will be 0, 1. So our initial starting point would be right here. So this would be when time equals 0, and then we would then jump to the next time slot, which is 1. So when time is 1, x will be 1, y will be 2. So when time equals 1, x would be 1, x would be 1, y would be 2. So it would be here. So this here would be when time equals 1. And then going back to here, when time equals 2, x would be 4, y would be 3. So when time equals 2, x would be 4, x would be 4, y would be 3. So that would be right here. So this is when time equals 2. So let's go back in time. When time is negative, so 0. When time is 0 here, when time is negative 1, x would be 1, y would be 0. When time is negative 1, x would be 1, y would be 0. X would be 1. Sorry, hang on, let me have a look at this again. When time equals negative 1, x would be 1, y would be 0. So x is 1, x would be 1, y would be 0. So that would be right here. So this would be when time equals negative 1. And then when time equals negative 2, x would be 4, y would be negative 1. So when time equals negative 2, x would be 4, y would be negative 1. So it would be here. So this would be when time equals negative 2. So you would then draw your curve so our normal routine would be to start with these two equations, create our table, and then from the table we can then draw our graph. But that's a slow and tedious way of doing it. Here's a much more efficient way of doing it. So starting with the two parametric equations, our aim here is to rewrite this in an algebraic equation involving just x and y, meaning we should eliminate t. So starting with this, rearrange it to make t the subject. So t would then be this, and then now we know t equals y minus 1. We can put it into here. So x would be this thing squared. So it's just a matter of eliminating the t. That will then give you this, and then multiply the brackets, and then that will then give you this. Now at the moment it's still quite hard to understand what this graph would look like, what this curve would look like. So if I were to give you this, let's forget about this for the moment. If I were to give you this, y equals x squared minus 2x plus 1, you could easily sketch this. You could complete the square on this, or we can just sketch this. When x is large, it wants to do a quadratic. When x is large, it wants to do a quadratic, and we've done this many times. So if you don't understand this, then track back to one of the earlier videos on how to sketch complicated graphs. When x is small, it wants to do this straight line here. So the straight line will have a gradient of negative 2, an intercept of 1. So that would be somewhere here. So when x is small, it wants to do this straight line. So you know when x is big, it wants to do a quadratic. So let's remove this a little bit. So and then completing the square, you can see that it will cross over dead on the it will just touch the x-axis. Well, we've done how to sketch this many times. From this, we can sketch the quadratic curve. Now, when you have this here, sketch it like this. Hang on. So imagine this as being y equals x squared, because all the x and the y's they switch around. So hang on, x squared minus 2x plus 1. So imagine this as this, and now sketch this. So when you sketch it, it will look like this: intercept of positive 1, gradient of negative 2. So I'm just going to guess something like this. And then when it's big, we want to do a quadratic. So it's going to look something like this. Okay. So don't forget this here. Looking at this here would be your x, and don't forget this is positive. This is going in the positive direction, and this here would be y. Okay. So now let's forget about this now. Now we are trying to understand this. Now, when you do this, we are trying to obtain this. We are currently at this graph here. So what we do is we flip. We ultimately want a graph looking like this: x here and then y here. So this is in the x direction. This is in the y direction. So the x and the y's they switch places. So we are currently here. We now ultimately want to get this axis here to be vertical. So let's hang on, let me think. So let's flip this and then rotate it. So hang on, let me just let me just move this down here. Bear with me. Hopefully it will make sense later. So currently this is our graph. Currently this is our graph. We ultimately want to draw a graph of x going on the top, and y going across. And don't forget this is in the positive direction, and this is in the positive direction here. So we are currently here at the moment. So we ultimately want to get the x going in the vertical. So hang on, bear with me. So let's hang on, let me think. Let's flip this. Let's flip this. Hang on, let's flip this horizontally, and then let's rotate it. Hang on, bear with me. Hopefully it will make sense later. And then rotate it. Okay, so hang on. Bear with me. Hopefully it will make sense later. So looking at this here, this is what we've. So now you can see that this is now. Hang on. Now you can see that this is x here, and this here is y. And don't forget this is our positive direction here, and y. This is our positive direction. Well, don't forget this thing here is very similar. Well, in fact, it should be the same as what's up here. Because if you look at this here is 1, and it should have a gradient of either negative. Yeah, it should have a gradient of negative 2. And then, well, this quadratic here is a bit like this one here. So hopefully you can follow that. Hopefully. So when given this here, you can still obtain that graph. Think it through for yourself. Yeah, I hope you understand it.